In this video, I want to have a look at finding the equations of tangents and normals to trigonometric functions. So we're going to just jump straight into an example. So our question asks us to find the equation of the tangent to the curve y equals sine of pi minus x at the point pi on 6, a half, in exact form. So we already have our x1 and our y1 of our function, of our equation, y minus y1 equals m outside of x minus x1. So we have our x1, y1, we need to find our m. So to find our m, our gradient, we're going to differentiate this function. So our first derivative is going to equal, now sine differentiates to cos, but we also need to multiply by the derivative of this inside function. So the derivative of this would be minus 1. So we're going to have minus cos of pi minus x. Now we want the value of that gradient at x equals pi on 6. So at x equals pi on 6, that means our derivative is going to be cos of pi minus pi on 6. Now pi minus pi on 6 is, oh sorry, that should be a minus there because it was a minus up here. So pi minus pi on 6 is equal to 5 pi on 6, because pi is equivalent to 6 pi on 6. So to solve this, we're going to draw ourselves a diagram. So we know that this is pi, so 6 pi on 6, so that means 5 pi on 6 would be up in this quadrant here, and our related angle would be pi on 6. We know it's all stations to central, so that means that cos in this quadrant is negative. So this is going to be equivalent to, we've got a minus already, but it's going to be equivalent to minus cos of pi on 6. So that minus minus is going to cancel out and it's going to be a positive, so it's going to be equal to cos of pi on 6. Now cos of pi on 6, that's one of our exact values, so we need to use our special triangles. So we know that we've got 60 degrees, 30 degrees, we've got 1, 2, and root 3. Now these triangles are on your formula sheet. Pi on 6 is equivalent to 30 degrees, so cos of 30 would be root 3 on 2. Right, so this is the value that we're going to have for our m in here. So now we can substitute in our three values. So we're going to have y minus a half equals root 3 on 2 outside of x minus pi on 6. And we need to go through and simplify that. So the first thing I'm going to do is multiply everything by 2 to get rid of these. So we'd have 2y minus 1 equals root 3. And I'm going to expand this out at the same time. So I'm going to have root 3x minus pi root 3 over 6. Now we've still got a fraction in there, so I'm going to multiply everything by 6 to get rid of that denominator there. So we'll have 12y minus 6 equals 6 root 3x minus pi root 3. And then I'm just going to write it in general form, so pull everything over to one side of the equal sign. So I'm going to pull these over this side. So we're going to end up with 6 root 3x minus 12y plus 6 minus pi root 3 is equal to 0. So this is the equation of the tangent to this curve at this given point. In our second example, we're asked to find the equation of a normal instead of a tangent. And we're asked to find the normal to the curve y equals 3 sine 2x at the point where x equals pi on 8. So there's a few things we need to do. We know that x equals pi on 8. That's our x1 in that same formula we were using in the last example. But we also need our y1. So y1, we're going to substitute pi on 8 into here. So we'd have 3 sine, and 2 times pi on 8 will give us pi on 4. Now looking at that, you should know that pi on 4 is 45 degrees, and sine of 45 degrees is 1 on root 2, and that's from your special triangles. So that's going to be 3 times 1 on root 2, which would give us 3 on root 2. But then let's rationalize the denominator there. So we multiply top and bottom both by root 2. And we end up with 3 root 2 over 2. So that gives us our x1 and our y1. Now we need to find our m, our gradient of the normal though. So just being a little bit careful with that. So we're going to differentiate this. So we're going to have y dash is equal to, the derivative of 2x is 2, so we're multiplying by that. So we'd have 6 cos 2x. Now we want that at x equals pi on 8. So that's going to give us y dash is equal to 6 cos of pi on 4. Because again, 2 times pi on 8 gives us pi on 4. Now cos of pi on 4, that's cos of 45 degrees, and from your special triangles again, it gives us that 1 on root 2. So we're going to have 6 on root 2 this time. But this is the gradient of our tangent, and what we want is the gradient of our normal. So this is our m1, but we want the gradient of that, which is going to be the negative reciprocal. So we're going to have minus root 2 over 6 as the gradient that we want for our normal. So now we have our 3 values. We can substitute those into our formula. So that's our y minus y1 equals m outside of x minus x1. So substituting it all in, we're going to have y minus 3 root 2 over 2 equals minus root 2 over 6 outside of x minus pi on 8. Now it's looking a little bit messy. Let's go through and multiply everything by 6 to get rid of these denominators. So it's going to give us a 6y minus. Now if I multiply this by 6, that 2 is going to cancel out, and it's like we're just multiplying by the numerator by 3 instead. So that's going to give us 9 root 2 equals minus root 2, and I'm going to expand this out at the same time, so minus root 2x plus pi root 2 over 8. Now I'm going to go through and multiply everything by 8 to get rid of this. So 6 8s are 48y, 9 8s are 72 root 2 equals minus root 2x plus pi root 2, and then bring it all over one side of the equals sign. So we're going to have the square root of 2x plus 48y. Hang on. That should have been an 8 in there, sorry. Once I multiplied by 8, I should have multiplied this guy by 8 as well. So that'll be 8 root 2. Then our minus 72 root 2 plus, no, because we're bringing it over the other side, minus pi root 2 equals 0. So a few little mistakes in there, but I think I've got them all out. So this whole long thing is the equation of the normal at this curve. Those are 2 examples of finding equations of tangents and normals to trigonometric functions.